I think we can start 2 o'clock sharp. So at least we take this opportunity because we are let's say, the first parallel session of the conference. So it's for us the honor to initiate the parallel sessions. I'm Vanda, Nunes de Lima. I'm working at the GRC in the Inspire team. I was coordinating the development of data specifications, and now I'm working with, let's say, with the Inspire team and the member states for the implementation and maintenance process, and using in particular the Inspire data, implementing it to at the same time implement other policies. How we are going to manage this session. So it's important that each of you, once you have questions, use the microphone, and also for the presenters, because the session is going to be registered, and we have 5 presentations. So we cannot go behind the 15 minutes allowed for each presentation. If you agree, we can allow a question at the end of each presentation, something that is very much related with the presentation itself, and other questions that are more general and that leads to more discussion. We will do this at the end, just for scope of saving time. So with that, I can give the floor for the first presentation. Mr. Pavel Šidlichovský, I ask you to introduce yourself. You do this better than I can do.
Thank you. So my name is Pavel Šidlichovský, and I will speak on behalf of Land Survey Office of Czech Republic. So from the visions of plenary session this morning, I will get you back to the implementation of Annex 1 themes mainly. Short overview of my presentation. I had to place my presentation in some perspective, but my colleague Mrs. Cikánkova did it this morning, so no need for this. Then I will speak a bit about our current services in Cadastre Office and Land Survey Office, about the way to national datasets, on the examples of hydrography and transport network teams. Then, if there is a time, I would mention a bit about our effort to edge-match datasets on the national boundary. This is how Inspire Directive was transposed to our system. It's a wall of text, but the important point is that the way it was transposed, everybody understood that all people are, or public bodies who own the data and are legally obliged to keep them, are also obliged to publish those data sets in Inspire compliant way. Maybe even at the time there was a hunch it's not maybe the best way. There was set up a committee for coordination of Inspire implementation as advisory body for Ministry of Environment, which then established technical working groups as their advisory body. But in the meantime, time was ticking, and it was ticking mainly for Czech Office for Cadastre, because it is responsible for maintenance of our base registry for territorial identification of addresses and real estates, and it covers the themes of administrative units, addresses, and cadastre parcels. It has to be considered the new or restructured data set, so it was obliged to publish its data by the end of 2012. And here comes into play my office, the Land Survey Office, because we are a subordinate office of Czech Office for Cadastre. We are responsible for other surveying things other than Cadastre, also for GeoPortal and its metadata and services. There was time enough for us, but we couldn't stand aside while our colleagues in Cadastre Office announced one service after another, so we had to get involved into the implementation and harmonization of the data as well. This is current situation of harmonized data which are published. I was hoping we can get the transport networks download service working by the conference time, but we are a bit late, so it will follow in a few weeks, I hope. I'm not going to speak about cadastre office data anymore because there is separate presentation on Friday at 9, so if you are interested in those themes, you are invited to this presentation. This is our very first service. On the left side, the original WMS. On the right, the view service for geographical names. First, we implemented because it was easiest to do, and we had to gain some experience gradually. This is just the feature info. This is a similar example for hydrography, only the physical water subteam, because the network subteam, we are waiting with it for the national dataset to be created. I would like to point out with this picture that I think it's very important to have the teams matched between themselves, because maybe you know one of the elements is so-called water crossing, and it's a bit silly when the element which has to cross the water crosses it next to water crossing. It's not, I believe, anywhere required, but it is done in our data sets. Again, some feature info. The toughest part was the transportation network, in this case the road networks, because the requirement is different than our source data set was structured. You know that there is required the links and nodes at every intersection, and our source data have separate feature type for every road class, and it is structured, it is intersected only inside the feature classes individual. So what we had to do to get to the final data set was derive all the nodes and segment the data freshly, which in itself is not as difficult, but the main challenge was to maintain the lifecycle information of the new derived nodes and segments, so that in repeated derivation we really have only the changed data change its unique identifiers. We were on the verge of coming to decision to restructure our source data, but then we managed somehow to make this transformation work, but still I wouldn't like my life to depend on the quality of this transformation. What we found out also was that there is quite a lot of missing transport properties in our mapping agency data, which we have to get somewhere else. Maybe you noticed I didn't give you any link to our services. That's because I would like you to access our data through GeoPortal, where is all the information gathered. It's in English as well. So I will give you just one link to bind them all, one link to find them, where you can get more information. As I mentioned, we don't have all the information required, and in this phase it was realized on the coordination committee level that there would be a large number of partial data sets which has to be harmonized, and it's expected to be burdened both for the responsible parties and for the users who then have to choose which one are fit for their purpose. So the decision was taken to aim at creating national data set for teams with maximum available information by cooperation of data holders, and to find one responsible party, if possible, for each team to coordinate the work. The challenges were to identify the sources and verify the different data which would be presented, and the main challenge at the moment is to find the responsible parties. The well-known table of teams, you can see the teams which are obviously in the responsibility of Land Survey Office, the green ones, the teams which go to Cadastre Office and the base registry. Those red teams could be already marked as a national data sets because they are such by law. And then there are the yellow or orange teams where we have some data. We would like to participate in creation of national data set, but we are usually not even the main provider. Example of where we stand with hydrography. This is data of our fundamental database, and in the year 2005, our data set, which was then updated, and now we are working on improving of accuracy based on laser scanning. We are keeping also topology with other teams, as I mentioned. And from this data set, there was derived just the water stream part for the purpose of Ministry of Environment. It was developed by their research institute, and it's basically a copy of the Baguette data, but it lives its separate life from the 2005. And then from this data set was derived yet one more copy of the data for Ministry of Agriculture and its water management institutions. So now we have 3 water databases living one to next other, and what to do with it? There was, fortunately, the Ministry of Agriculture and Environment came to agreement, and they decided there will be a single data set which can satisfy the needs of both ministries. And then, was approved by a bill of Ministry of Agriculture, it was decided that our fundamental base geometry is the binding one because it's better, and it would be used as the base for this united register for the ministries. And we have to set up the synchronization through web service or some other method. But of course, first we have to synchronize the contents, which is a challenge ahead of us. When it's done, we can publish our updated geometry to the national INSPIRE dataset and supplement it with any missing attribute information from the United Register of Ministry of Agriculture and Environment. With transport networks, very briefly, the same problem we had, that there are separate road classes, is even more important because separate road classes are in the responsibility of separate state or local administrations. So this is going to be a big challenge to create one data set. Fortunately, the responsible party in this case is Ministry of Transportation, but we are of course going to participate as much as we can to help them to get to some reasonable result. It's my strong belief that without one centralized database system we can't maintain this data set at all. The last point, from the year 2009, we are working on harmonization. That's a terrible word. It has origin in our project, which started this process and was funded from European money. But you can substitute the harmonization with edge matching. So we started with Saxony, then we extended this experience to Bavaria, Czech border, outside of the project, and this year we met with colleagues from Poland and Slovakia and agreed to continue this work on our common borders with the plan to finish this edge matching in 2015. Some prerequisites for this successful edge matching is the existence of well-defined international boundary, which we can say we have, although the coordinates are treaty level only at 2 boundaries. We have to implement this international boundary into the data sets we want to edge match. There we have some reserves. And of course there has to be known, well-defined and implemented coordinate transformation. And there will be, is and will be always some kind of inaccuracy or problem. We have 2 transformations, one official, which is very accurate but also very complicated. It adds some corrections from correction grid, which is not easily integrated into the commercial softwares. And to overcome this complication, we adopted the strategy of connecting points, which are created as feature types in both edge-matched databases. So in this way, we have an anchor which keeps the edge-matched process once it was once run for the future re-edge matching if necessary. But I don't believe in possibility to create the first edge matching run automatically, because we identified a number of occasions where one country assumed something which the other country did not. So there is a number of features which end on the border and don't have any partner on the other side, although they could. So it's about dialogue, about feature by feature, occasion by occasion. This is example when both countries expected that the water stream goes through the other country territory, and we had to meet and find that it is actually almost concurrent with the border. So then both data sets had to recreate this. Okay, conclusions. It's my belief that inspired datasets, to be useful, should be edge-matched on dataset or international boundary and matched throughout the teams. And I believe it's not possible or hard to do when there is multiple datasets for teams. So I believe single dataset per team per country is convenient, and for some teams, mainly the network teams and those which use tessellation like land cover, land use and so on. Also the single publication database per team per country is convenient or necessary to be successful. That's all from me. Thank you.
Thank you. Thank you, Pavel. I give the floor for one question regarding to that may help to clarify. Yeah.
Yes, Natalie from Belgium. Yes, I see that you have also for the transformation of the road network, and with this model of dynamic segmentations. And I see that you have decided to derive, in a way, the life cycle information, providing unique identifiers for that purpose. Is that right?
I'm not now. Sorry.
Yeah.
I'm not sure. Could you simplify the question?
Yes. So I want you have in fact identifiers on your data sources, but in a way, if I have understood well, you have derived or generate automatically some Inspire identifier for the purpose of the new segmentation.
Yes, that's correct.
Okay. So I think that indeed in our data sources we are facing the same difficulties. And well, the idea is, I would be really interesting on the way you have, or the rules for deriving this Inspire ID. So, but we can have a talk or information on
the deriving of the Inspire IDs was pretty simple, but the challenge is to keep those IDs when you create the data or run this derivation again. So yes, we have some rules for this, but I am afraid I can't answer this in 2 sentences.
No, I understood well, but if I can, I am interested by your rules, if you could provide it, or I'm interested to have your approach.
It's probably for a longer explanation.
Yes, not here,
later.
But
yes.
yeah. Okay.
Okay. Thank you. Oops. Thank you. We need to pass to second presentation. Thank you, Pavel. Now it's Maria Cabello. And we go to a different type of presentation. Here we have the results achieved when making Inspire compliant an European data set. Okay, you can go there.
Yes, I think I have this one.
Sure.
Okay, so good afternoon. My name is Maria Cabello. I'm coming from the public company Tracasa in a region in the north of Spain. I will try to present our experience on one real data transformation, but at the end will be probably also a demonstrative, as I will explain during the presentation. It's a project with the European Environmental Agency and is related to the theme from Annex 1, protected sites. So the summary of the presentation will include a background, why we are here and why we are trying to explain to you the way we have been working in this project. We will talk, I will talk a little bit about the project itself, about the harmonization process we have been following in this project, and finally we will try to share with you the lesson learned that we have from this project right now. That is not completed, so we are still running on all the process, and the deadline for this will be at the end of October, just including some additional validation with EONet network countries. So this is something that we cannot explain. So our experience came initially from several European projects in which we have been participating, from EURADIN, NaturSDI, HLand Data, BRISEIDE, SMSPIRE. Nowadays we are also in the GeoSmart City project, but also from other European perspective, from the regional to national level, and of course on the INSPIRE wider level. And in this sense, we have already performed some kind of transformation of data related to Annex 1. Well, this works, this not works, this is not. I don't know what.
Why disappear?
Yes, okay. It's here. This is probably this one. Yeah. That's it. So from the Annex 1 on the address is some protected sites related to EURADIN and NaturSDI+. On the Annex 2 and Annex 3 land cover land use related to the HLand data, and habitats and biotopes, species distribution and biogeographical regions related also to the project NaturSDI+. So we have been doing this from several years, but I have to tell you, this has been only on the demonstrative aspects, because none of these themes has been really implemented in a real operational world, so only as demonstrative. So the main, the project we are just speaking now is the Common Database on Designated Areas, which name is known as CDDA, the acronym, in conformity with INSPIRE. This will give you some of the clues of this project. We try to evaluate this European CDDA dataset, but I have to tell you, it's not only European, but European Union countries, but also some other countries outside the European Union, so countries like Albania or Turkey are also included. So the main purpose of the project was just trying to evaluate what the European Environmental Agency had regarding these data sets, CDDA, following to the design and transformation workflow, to develop and document the conceptual mapping rules. One of the main aspects we consider is that in some cases we can have a more wider view, more wider perspective, but when we do go to the real data providers at the national, or in our case regional level, they don't really know the expertise for understand the implementing rules, the conceptual data modeling, the data model itself. So this is why one of the main aspects we are facing is just trying to prepare a very good documentation that could be very helpful for those countries that need to face this transformation, but they don't know how really proceed with this. Of course, one of the objectives is to transform into GML, provide also an approach for how to do the validation, the quality of this data in conformance with INSPIRE, not about the data itself that is on the data provider side, and finally identifies and open issues and draft proposals for updates. We are very close also to the MIC team, and we are trying to provide as much as possible all the concerns we still have and how to proceed, maybe in GML, maybe in validation, or how to extend the data model. So we are running in this way that we think that is the best way for us and for future data providers just proceeding with that. So, starting from the harmonization process, I have to tell you this is something that you probably have seen from several years ago. We have followed this schema that has been structured in 5 steps. This is coming from our experience in NaturSDI+, and we have been applied in several other projects, not only us, but other partners of this project in their new projects or activities. The main aspect is that just trying to transform CDDA into INSPIRE, protected site data specifications. We have very well identified which is our source data model. We also have our target data model that is the simple schema. On the project, it was expected to also trying to transform into full schema, but on the last version from April, it was skipped from the data specification. So this is the reason why we only keep on the simple schema. On the conceptual mapping, we are using something that has been just mentioned mainly in all the transformation process, that is the matching table. For the tools for transformation, we have trying to use mainly open source or free tools. GeoConverter is a tool provided by my company Tracasa, and is going to be free of charge. Next week will appear the new web, and probably you can download and try to test. And for the validation, we have also used the proper tools of validation from Hail and some additional Oxygen and XML Spy just for as XML editors. Those are the procedures. I will try to follow this for explaining where we have been facing the different challenge. So this is only for you to see this is the common database on designated area, the CDDA data model. From all the data model, we only have identified that in some tables, the attributes for mapping with INSPIRE simple application schema. I have to mention also that in this case, we are trying to go not only with a very basic transformation or very basic number of attributes, mandatory attributes, and some other. No, we are trying to go into the full simple application schema and try to provide all the voidable elements as is included in the data specification. And this is, believe me, one of the main challenges we face at the beginning. So this is the INSPIRE protected sites data model. All of you know pretty well about them. On the first step, trying to analyze the CDDA, we say that we start to think on how my data model could match with the target data model. And for this purpose, this is why I include here the matching table. So we have in mind since the beginning. Another aspect we face is that trying to transform all the information from the different countries. We are talking about more than 92,000 polygons, and well, at the same point, we tried to do we thought about doing in only one step. All the information just provided as only one GML. But this faced some problems, probably not for creating the GML properly, but later on for the validation. And this is something that we have been trying to follow since the beginning, how to validate these aspects. And the other question about the voidable properties, that can be voided in Inspire, but we try to complete even those attributes. So the challenge we face, how to create a unique identifier. I'm talking on the first analyze, how to create the unique identifier, how to designate a site, the relationship with the legal basis, so the laws that are included in the CDDA and could be also part on the Inspire protected sites, the relations between the graphic and alphanumeric. This information is provided on one file, all the alphanumeric information, and on a shape, all the graphical information, points and polygons, but we will see that how we proceed with this. And we also face the possibility to propose some schema extensions. This is just to go into the detail, the different attributes we have. Here you have in some way try to explain that some of them are very easy to map, we will see how, and some of them were more complex and requires a lot of agreements between the experts in the thematic, technicians, experts on GML encoding, how to encode. So those are the major constraints. I will be faster. So for the conceptual mapping, we will face matching table. It was not difficult, rules for encoding and treatment of voidable elements. And here you can see all the elements that are included in this protected sites data model. For the geometry, we decided to use only polygons. And for the Inspire ID, the two mandatory elements, local ID that is a direct match with site code, that is one of the attributes of the table, and for the namespace, we knew that this is something that is on the side of the data provided. But anyway, we had to face to create a unique identifier for this purpose of the CDDA, and we decided to create in this way, just to be able to go into the all information. And so it's like a formula we use. For the legal foundation date, it was not in the right format, but in an easy way, also with a formula, we can transform and encode properly in date time. And for the legal foundation document, the mapping was not possible, but the reason was mainly we had some information, but on the CDDA, the purpose is on a global level side, so on the national side. And in the Inspire data model, the purpose is on the site level. And we don't really have the legal foundation document, that is a document that indicates where this site has been regulated by law. So I will go faster. So this is the reason why. For the site designation, we try to extend the Inspire data model, and this is something that is proposed also. And for the site name and site protection classification, from our perspective, no problems were. For the transformation, as I mentioned, two tools that mainly do the same things. The most important here is that read XSD schemas and export to GML 321. And this is the encoding rules challenge. So the one with mainly with red, that mapping is not possible, or the site designation will be more in detail. On the legal foundation document, this is the way we decided to encode, so just is a voidable reason and the nil reason is unpopulated. But when information is available at data provider, we have to fulfill or include two attributes, title and date. And this is the way we agreed to encode those attributes. We presented also in a workshop last Monday in the afternoon. If you are interested, we can go in detail in this. For the site designation, that is the one we decided to extend, it was tried to extend with 2 new designation schemes because on the INSPIRE perspective doesn't consider the national designation scheme, so this is the reason why. These are the 2 extended national designation code and category, and this is the one appearing in INSPIRE, and these are the 3 ways to encode the different attributes. The most important here is that we have decided to use 100% in percentage and the designation, and this is not considered in encoding rule. And also we have been using the -1 just because if we don't know which is the percentage, so this is one of the open issues we are trying to share also in the GML encoding rules, how to proceed with this final encoding, and this is something that we will move on the right way when we can reach an agreement. And for the site name, this is a way we have encode, is a geographical name type, and according to this, only 2 elements will be enough under a spelling of name, but in fact, this is not possible to validate. But if we go to the whole geographical name, then the validation is possible. So this is something that we have to consider for the purpose of the final quality or conformance test. And on the final test, we have considered 2 basic and advanced validation. A table is provided here in which we try to cross the information from the different tests, and our vision on how could be validated all this. Important is that we are talking about extended schema related to the protected sites and a specific schema more related to other aspects like is datum or coordinate reference systems and so on, and some others that could be done on the data provider basis, but not really on our perspective of transforming the data. Finally, those tools we have been using for this purpose, I mentioned before, and for the publication, I'm not going to go in detail because it's out of the scope. Lesson learned, and I finish, sorry. Definitely, thematic experts on the thematic are really needed. They don't know much better than any of us about the data model they have. So just talking with them is absolutely necessary. Be aware, conceptual mapping is not an easy way. It's really time demanding. We have spent a lot of time just trying to reach the agreement with the thematic experts, with the experts on encoding, with the experts on transformation, and this is really time spending. But we see that we have now a realistic approach from this conceptual mapping to GML encoding, and we try to share this information of the process. This is why we are today just, apart from the workshop, in the other room is also the project manager on the European Environmental Agency presenting another perspective of the same project. The right encoding is also trying to manage with the MAKE group, so hopefully in the few, let me say, days, weeks, we will have the final encoding rules prepared to be definitely shared, but still we have some concerns on how to proceed with this quality and validation, and for us is now the main issue. So I invite you also, I know that here is Giacomo, that we are very close just to try to find the way on how to best validate, but this is something that could be the next step, not only for us, but hopefully for all of you. So if you reach here, then we will be prepared to be, we are conformance with INSPIRE. Thank you very much.
So, thank you, Maria. Just a very fast question.
I'm Birgitta Olsson from the Swedish Environmental Protection Agency. I just have one question. Since we have our database with the protected sites and we have them aligned with INSPIRE protected site schema, the full schema, and we also have another way to publish the CDDA reporting. And now you are transforming the CDDA into the simple schema. Have you tested to use our Inspire services directly instead of going using our CDDA reporting?
No, this I have to explain you that this is a project that is managed from the European Environmental Agency. They were trying to offer some solutions, easy solutions for those countries that they don't really are facing the transformation in an easy way. So this is why they know that the CDDA, well, probably you also know that CDDA has a flow. This flow until now is not changing, but we really know that the real owner of the data are the countries. In the future, this will be the way of trying to compile this information on the CDDA. So this is only one step in which they are trying to help some other countries. They are in fact organizing some meeting with the EONet network to present this project, to see how it's received, their feedback, but we are not trying to test what you could have already done, because this is something that will be the next step.
Okay, but I'm just interested to get rid of one of the ways. Either I can do the CDDA or the Inspire. But I think it's silly to do both if you are transforming the CDDA. That's my point.
But is the only data set that they can organize in some way and try to test and try to transform. Okay. Yes.
Okay. Yes, thank you.
Thank you.
Just to add, let's say, to this point, which is very pertinent, we still have to include in the maintenance and implementation process, and hopefully in the work program of MIG, the harmonization between the protected sites and the teams of an X3. So habitat, species, and geographic regions, and included on that package, it also may be, of course, the, let's say, look at the full data model for the protected sites. So this will be still, let's say, to be included as a final check, because at that moment this harmonization is not guaranteed at all. So we pass to the third presentation. We can come to these issues if we have time for discussion. And the third presentation is regarding a project. And the first speaker is Mr. Alkis Astyakopoulos, and he's going to be helped by Giacomo.
Good afternoon. I'm of course not supporting Alkis, but just we are sharing the topics of this presentation, which is an experience of how to use the land cover data specification in the frame of the eENVplus project. So I will talk about the more technical stuff related to the data transformation itself, and Alkis, my colleague, will talk about more generally about the project scenario of forest fires in which this exercise has been done. So the problem targeted. Forest fires management requires knowledge of the so-called fuel classification maps that are poorly available in the Mediterranean countries, since they are produced only at local, at regional scale, without any regular updates and or not using standardized methodologies. This is a requirement coming from Europe. Therefore, available fuel classification maps cannot support the systematic use of forest fire modeling at operational level. And what are in more details? So forest vegetation is considered as a fuel, and its structure and status govern the dynamics of a fire. And this is the reason why fuel models and their spatial patterns are significant for management actions of forest fires in all the life cycle, from the awareness phase to the emergency phase to the impact phase and to dissemination phase, about the lessons learned. The this is part of one of the pilots of the eENVplus project, and one of the output files of this pilot is the so-called fire access time, which is produced using a methodology developed in the frame of a LIFE project, which in turn is an input for a forest fire simulator. And this fire access time is a process of cascaded steps based on the use of a multi-temporal Landsat thematic mapper images for the distinction of fuel classes with different seasonal characteristics based on NDVI, and further refinement based on ancillary data such as burned areas, canopy cover density data derived from satellite observation. Most of these data come from also JRC studies from the fuel expert, from the forest fire experts. First of all, the exercise is the fitting for purpose analysis to detect the best suited data specification, and we decided to use the land cover we deeply analyzed. And the land cover data specification does not prescribe or recommend any particular land cover nomenclature for use in INSPIRE, but instead is allowing many different land cover nomenclatures to coexist in the context of INSPIRE. That's it. It was the most suitable one to use. There are these application schemas, because we know that for each of the theme there are more than one application schemas to be that are offered for the different use cases. And so there is the land cover nomenclature application schema, the land cover vector application schema, and land cover raster application schema. In addition, there is also an extension to the previous one. This is the UML package. And so the land cover data are modeled through one of the two core, the so-called core application schemas. The land cover vector defines a vector representation, or land cover raster defining a raster representation to support land cover data. And according to the requirements coming from the project, we selected the land cover raster application schema using the external file option for the encoding of the values of the pixels. And in order to physically implement this option, we followed all these references into the document of the data specification itself. Land cover, just a quick look about the major feature types used to make this exercise. And since land cover raster application schema models land cover data as rectified grid coverages, the ArcFuel spatial datasets, so the outcome of the Landsat thematic mapper images has been mapped to the land cover grid coverage feature type, and these are a snippet of the GML harmonized file. In accordance to the constraint domain rectified grid present in the rectified coverage feature type, the domain of the coverage, the domain set attribute has been encoded as a rectified grid, and here are the examples. And considering that the final ArcFuel output is a file-based dataset, the range set of the coverage, so the value of the range set attribute in the coverage feature type, has been encoded using the Xlink href attribute for referencing the T file. Here is the example. And about the nomenclature, also all the requirements to refer to external nomenclature with an external file has been used. These are the 20 values used for this raster file. And this is an example of the encoding of the relevant nomenclature. In terms of validation, full conformity with respect to the 7 tests of the conformance class A1 application schema of the ATS has been achieved and documented. And a detailed presentation about this validation will be given on this presentation tomorrow. This exercise, very important, is fully documented in 3 best practices available in the INSPIRE best practice catalog available on the website, particularly related to the first one, how to encode the full exercise. You can download the GML and to see how we made, and also how to assess the degree of conformity of the requirements specified by the part of the validation, and also the part how to produce both the metadata for discovery and the metadata for interoperability. And I would like to pass the floor to my colleague Alkis to explain how this work has been in the overall framework of the project pilot.
Okay, thank you, Giacomo. Just on this part of the presentation, I will present you how Inspire is part of a bigger workflow of our forest fire management system, which is called ArcFire and developed by Epsilon International SA located in Greece, in Athens. So the ArcFire system is a state-of-the-art technology integrated wetland and forest fire management platform under constant technology evolution since 1990. It is currently offered to civil protection authorities and national, regional and local authorities for their use. Its aim is to guide operations and protect our forests in Greece, but not only in Greece. Any kind of pilot can use this software, and the platform is fully customizable in order to meet any kind of client's needs. Here is the overall architecture of ArcFire system. As you can see, it makes use of the classical three-tier architecture. At the bottom side, there is the database server where the GIS, meteorological and fleet management data are stored. In the middleware layer, we have developed a series and different type of services, and very complex services, I would say. For instance, the static map service, the forecast map service, the map index service, the total risk map service, the fire detection service, where we detect the fire using cameras established into the forest. The fire simulation service, the fleet management service, the evacuation service after the ignition of the fire, and after the end, the flood risk service. These services have been integrated and provided directly to the clients using a mobile or a web application. Now I will give some more details, technical details about how the static map service and the fire simulation service works, and how it makes use of Inspire implementation and transformation according to the Inspire specifications. So the technology used for these two services, we mainly used, for instance, the asynchronous ingestion service, where we create spatiotemporal data, mainly meteorological forecast and indexes. These data are ingested to the eENVplus project SDI, and returned back to the user via OGC services like WMS, WCS, and WFS. On the other hand, we developed WPS orchestration, where mainly we calculate the fire simulation, the fire access time, as previously mentioned by Giacomo, which is an Inspire compliant dataset. And then, except from that, we calculate the total risk map, combining a series of services and an optimal route avoiding the fire. This is a more technical representation of the modules developed into the ArcFire, these two ArcFire services. Just to let you know that we are using, for the ingestion, the GeoBatch technology. The data are stored into a spatiotemporal data warehouse, PostgreSQL, using the PostGIS extension for the spatiotemporal datasets. The layers are geo-processed using the Geo server, and also we have developed a WPS wrapper, which mainly uses some of the data stored into the Geo server and feed a service that makes a simulation of the fire. This is the activity diagram in more detail. We used many functions until to go at the end and to provide to the users the fire simulation output, which is the fire access time. So we start with the begin function, which sets the parameters to download the raw meteorological data for all the active pilot areas called scenes, and they are called scenes because we can have more than one scene. We can have more than one pilot area here. The bound box is defined with particular coordinate system and specific resolutions. For instance, we are using a 20 meters resolution. And all available and activated scenes are stored into an XML structure which contains only one data type called meta territory. The specific function, this is the first function, copies the XML attributes into the root directory of the machine where the service is running. The second function is the start area, where queries the FTP services given by the meta territory in a sequential order. In our case, we are using a meteorological provider from the University of Athens. If any problem occurs in this query, the function attempts after 10 minutes, and then if the FTP area fails to respond, the function searches for the next available FTP server. So we can collaborate with more than one meteorological providers here. Then it compares the structure folder available on the FTP folder structure, again the sets of raw data already downloaded to the system, and then starts a thread for each day missing and is not prior to the server installation date or the last backup date. Then the next function is the make data function, which downloads the raw meteorological forecasts, and these forecasts are mainly 7 parameters for each day missing, and usually there are 121 files. That means per hour for 5 days forecast. The function keeps the names of the files as given by the FTP server. So we are using, this is the first pilot we have developed, the Seixou, which is a suburban area in the northern Greece, area of Thessaloniki. So we were using underscore LLL, which is the name of the parameter, and HHH, which is the forecast horizon between 1 and 121. These are the parameters collected from the meteorological station. Then the data are parsed one by one and separated into 7 blocks, one for each parameter, and stored into the database. Then a function of transformation is needed because wind speed has to be calculated in meters and seconds, the wind direction in degrees, the temperature has to be transformed from Celsius from Kelvin to Celsius, and then the rain precipitation has to be calculated per day and not per hour. The forecast function is the most important function, which georeferences the raw data to forecast maps and resample data at higher resolution from 1 kilometer to 20 meters, as I previously explained to you, and then creates 7 sets of 121 ASCII files and stores them to the database. And all this data are stored into the database with a specific name convention, as you can see here. The ICGen is also one very important function that creates 8 important and added value meteorological indexes needed to create, needed to forest fires and create this fire simulation output. These indexes are stored again into the database with the same name convention. The interface A, which uses the GeoBatch technology, collects the categories, zips the package, and send them back to the eENVplus Azure server. And these are all the datasets produced along with the new indexes. So it is the fire maximum linear intensity, the cloud coverage, the dead field moisture, and all these datasets are produced directly from our system. And at the end, we run the ArcFire web service, which defines the boundbox. The ignition points are given by the user, and the simulation date. That means how many hours or days you want to run the simulation. And then we request the necessary data using a WCS get coverage request, and we run the service. The main datasets that we use for the simulation engine is the aspect, the slope, the fuel model, which is what Giacomo previously described to you, and except from that, also the dead field moisture, the wind direction, the wind speed. All these datasets feed our service, and then we calculate the simulation of the fire using a cellular automatic analysis process, and then we return the results and the statistic back to the users. Many thanks.
Vanda, excuse me, just a few seconds. I forgot to mention that in terms of validation, the other single tests of the other 6 conformance classes of Part 1 normative are in progress, and that the same harmonization procedure we recently started with a Copernicus imperviousness dataset, so it can be very easily reused.
Yeah. Question from the audience? No question, so I can ask one. Why you decided to use land cover only and not any other of the themes that may be of relevance for that application?
When we started to identify, like in all the other pilots, at the first glance, I think we had, I don't know how many data sets to harmonize, particularly for the environmental monitoring facilities, all the input parameters for the process, which will be harmonized at the next phase. We started with the output file in order to feed the flow of the workflow with an harmonized data set. But it is planned to do.
Okay, it's coming. So thank you. So the fourth presentation, Magdalena Gugala. I'm wondering if it was a problem with the work program, because we have two versions, with and one without. So if there is not that presentation, it means that we have more time for discussion at the end. I'm sorry. And we go to the final presentation, which is the presentation done by Sören Dupke. What is yours?
This one. It's all right, thank you. Yes, thank you, Vanda. I'm going to talk about a project that he does this year with the German Federal Institute of Hydrology. It was only like a prototype to evaluate some solution to harmonize the INSPIRE relevant data at their institute. This one?
Yes, sure.
Okay, so first of all, I'm just saying a few words about what the BFG, it's a short form of the German Federal Institute for Hydrology is, and what kind of data they keep. Then I'm going to talk a little bit about the approach used, about the matching, the mapping, and the publishing. So the way how we first did the conceptual aligning of the data models they had with the INSPIRE data models, then the actual implementation with FME and INSPIRE Solution Pack, and finally the publishing with ArcGIS for INSPIRE. And then afterwards I'm also going to go on a bit about the lessons learned and the current status of the project, because unfortunately we couldn't finalize everything because Mr. Fretter, who also was planned to share this presentation with me, is ill at the moment, so we are not as far as we wanted to be. So if there's any thematic questions, I'm sorry that I may be not as good in answering these questions as he would have been, but I hope it will still be interesting for you. Yes, BFG is a higher authority of the Federal Republic of Germany under the auspices of the Federal Ministry of Transport and Digital Infrastructure. And their main task is to be to support the federal government in terms of research, assessment, and consulting in the fields of hydrology, water resource management, ecology, conservation of waters, and they also support the federal waterway management administration in managing and building new waterways. They are originator of a couple of data sets, as well as administrator for data sets that they manage for other water management authorities in Germany. All their data is publicly available on the geoportal. That's also available on the web, geoportal.bafg.de, so don't be confused. It's not BFG, but BAFG. Okay, so first of all, we started with identifying the data sets that we wanted to take care of in the prototype. So here's a list of the data sets that we found. So it's basically data sets from Annex 1 and Annex 3. So there's hydrography, area management, human health and safety, and natural risk zones data sets. Since our technology, or the technology that we wanted to use was ArcGIS for Inspire, there's two different approaches, because I don't know how many of you are familiar with ArcGIS for Inspire. They're using, there's geodatabase templates that are used, where you store the data, and then on top of these geodatabase templates, the web services are created. And at the moment, the geodatabase templates are only available for Annex 1. So we had, also we could use these templates for the hydrography data, but we couldn't use any templates for the Annex 2 and 3 data. And there we followed a different approach. So we created the GML data directly and published this data using atom feeds, which we directly created from the catalog service, also using the Inspire solution pack. So yeah, this is just another way to describe this approach. So the old approach, or the approach that was already possible, is the top one here. So we directly go from the source data at the BFG using the transformation with FME and Inspire solution pack into the S3 geodatabase. And now for the Annex 2 and 3 data themes, we create Inspire GML directly and then publish this using ArcGIS for Inspire as well as atom feeds. Okay, so just to give an overview, the data sets that we published with the old approach or with the geodatabase approach are the river basins that are belonging to the Inspire theme of hydrography, and the surface waters which are also part of hydrography. All the others we created GML directly and published them as atom feeds. Or yeah, we are planning to publish them as atom feeds because we are still in the process, so to say. Yeah, so the approach for the Annex 1 data was to do the matching and matching tables. They are very similar to the matching tables that are also published on the Inspire data specifications website, just a bit aligned to the S3 geodatabase model. Then in the mapping, we used FME and the Inspire solution pack to harmonize the data to the existing geodatabases. Yeah, I think I already spoke about this. So this is one of the matching tables that we produced then. So on the left side, you see all the relevant features and attributes from the Inspire table, the geodatabase table with the description and so on. Oh, that's something missing here. I think I took the wrong. No. So here's the finalized, or it's maybe also an intermediate version of this table. So where we have the target model filled in here as well. So we have, for example, a field that's called, or a table that's called EZG. That's Einzugsgebiete. And then it's the class, or the feature class is polygon, and then there's an attribute shape which we use for the geometry field in the hydrography, for example. And then we have an operation that we apply on this field, so we just copy it basically into the Inspire model. There's can of course also be different operations like concatenating attribute or doing different things. So that's basically the approach that we use to do the conceptual mapping to specify the rules that we then implemented in an FME workspace. So this is basically one of the simplest workspaces that we had. So we have I don't know if you're familiar with the Inspire solution pack. So the Inspire solution pack is a product that we use to make these mapping processes easier. So we provide templates that basically already have this right part predefined, and with like code list values with the identifier creation and these kind of things. So we basically fill out these transformers in FME first, and then we continue with the individual mapping on this side, and yeah, then we can just produce the geodatabase that we then can use in ArcGIS for Inspire to publish the WFS web services. And then for the Annex 3 data sets, the matching was conducted in the Inspire matching tables. Basically, it's the same approach, just that they focus on the GML implementation of the Inspire conceptual models. Then we did the mapping with FME and Inspire solution pack to directly write GML and publish the data as atom feeds. So these were the data sets that we then used for these for the second approach. I just put in one another example. So I think it's basically the same like with the other tables. So on the left side you see the source model, the target model, sorry. Then we have the source model on the right side, and also the operations that we apply. And we also added some additional fields where we documented if certain information was not available in the source data, for example, or if there was additional information necessary that we had to get from the other data sources, for instance. Okay, so this is the finalized workspace. We will also provide templates in the Inspire Solution Pack 2.0, which then will have like a predefined part for GML writing as well, because at the moment it's only available for geodatabases. So that we again will have like an individual mapping part and a predefined mapping part as well. Then the second thing that we did is, since all the data was already registered in the catalog web service, we just created service entries in the catalog web service, and could then process these catalog web services with FME directly to create data set and service feeds for the atom publication of the data sets as predefined data sets for Inspire. The current status is so completed or almost completed are the matching tables. There are still some issues with some of the data sets that we have to solve. For example, we discovered some attributes that we would like to fill in the target models, but which are currently not provided by the source data. But like Maria already said, there's always a lot of things that you can do better, and so we gave this feedback to the like people who produce the data, and then try to enhance also the source data models to include this information there. Some of the things, of course, are still in discussion. Then the mapping, all the tables that we created are already implemented in the matching tables, according to the matching tables in FME processes. And since we didn't have the time to finish everything, the networking services are not created at the moment. And I just realized when I was here from another workshop that the Water Framework Directive feature models moved to the Water Framework Directive schema, so it was changed with the newest revision of the data specification, and so we will also have to take care of changing this in the data that we created. That's it basically. I think I was even a bit faster than I should have been, but it's due because Mr. Fretta was not here to maybe provide more thematically insight on this, so I was basically keeping it to the data harmonization aspects. But I hope it was still interesting for you, so thank you.
Okay, thank you. So I give the floor for one question specific to that presentation. No. So we can then start the discussion regarding. Oh yeah, I didn't see the.
In fact, it is regarding the Inspire schema and that you are supporting with the Inspire Pack solution. I think it was yesterday we had a workshop on the data transformation, and well, we have of course some Inspire information, but sometimes there could be a willingness to extend the Inspire data model because we have more information than what Inspire has expected at first step. Is it something that we can manage in your solution pack?
Yes, you can. The FME 2014 GML writer is now completely application schema aware, so you can basically load any GML application schema. If you extend the inspired application schemas, you can of course also load these extended application schemas, and will then be able to write to these GML data models. So
Okay.
Yes, it's possible.
Yes, thank you.
Yeah. So we have now a quarter of an hour for discussion, all about all presentations, and we have different types of issues tackled by each one of them. So the first one presented the very nice aspect where the data transformation hands to the services. So a very comprehensive overview of the whole, let's say, of the whole story. We have issues that are identified with the second presentation when making the transformation based on a data set that is provided and set up with the data sets coming from countries where certain types of data can be lost between. Still facing the problems of how to map, in that case, what is in the source data set to what is in the Inspire data models, and certain uncertainties, and the need in that case to go to the Inspire mix, so the group that is dealing with implementation and the maintenance, just to solve also, among other things, this type of issues, to get the correct interpretation, and when necessary to get the necessary update and corrections if what is the technical guidelines is to do so. So the third application, the third presentation showing a different aspect, so making data transformation to use this data transformation into a service where it's still not yet completed the full set of teams that are necessary to be, let's say, if you want to talk to be Inspire compliant at the end of for all aspects of the service. And the fourth presentation that he more or less pointed out the same issues, open issues that others, being what to do when we have more data in our let's say in our so the model that we are using, so regarding the team of Inspire, and we don't find the data on the source data. I don't know if any other issue you want to highlight from your presentation. So, floor for discussion.
I take the opportunity of this session and the presence of the chairwoman Vanda, and starting from the presentation of Maria, because we are talking about data harmony. And we saw in the second presentation that there is a CDDA with a data model coming from one European institution, which is the European Environmental Agency, and then we have the protected sites. Then we are aware of other similar situations in which other thematic directives having their data policies, they are using their data models which a different level of speed they are going to merge with the relevant Inspire data specification. So my question is, who is coordinating this harmony, and which are which is the timeline in order for the user community to achieve on a harmonized data model aspects of all these themes, because we are entering into the Annex 3 implementation phase, which is also very relevant to this aspect.
Question for the audience or for me?
I think for you, but probably is open to anyone who wants to contribute.
Yeah, I think it's good to have the contribution of the audience. So my first, let's say, first topics for that harmony. This is the scope of the MIG, first of all, because from different reasons. In some cases, because of the technical guidelines, can give still room in one way or another for different interpretations, but it also may be the case that other user requirements are coming up when you are using the Inspire frame for your specific application. But it also can be that once we start implementing, we realize that let's say slightly different things should be considered, and in that case we need to revise once we put so this harmony between teams. We know that in most of the cases it's team-driven, the implementation of Inspire, because first in many cases, countries identify who is responsible. So it was also a question. I think it's a difficulty and also a challenge and also a good opportunity for many countries to going through this exercise on identifying who is responsible for doing it regarding different data sets and different teams. But at a certain moment, those once this is identified, then we come into the reality of other than data sets compliant with INSPIRE, we have use cases. So what we have to do in the real life, what the public administration has to do regarding the use of the data. So as we heard today in the plenary and the days before in the workshops. So yeah, so for that, so other than the MIG, which is let's say all the process that is established and is going on to make this harmony possible, it's also the issue how each data producer and first of all how the country see INSPIRE in its internal let's say process, internal governance process. INSPIRE is not to be done for the only scope of doing INSPIRE, cross the box, saying at the end, once we define what does it mean to be INSPIRE compliant, which is also an activity of MIG at that moment, a subgroup of MIG. So it's not just to cross, and once we are going to monitor and reporting how far let's say INSPIRE have been implementing, cross there saying that how many services and how many data sets are compliant. But if this is to be implemented in the view of having services and of having, first of all, the use, let's say, the best use for the practice that the public administration and public and private authorities has to do and in the service of the citizen. So, and being one or the first or the second, the main driver for implementing INSPIRE, of course, the harmony goes into very different places. And it's going to be defined by different, let's say, different players. And I think it's good for the whole community if this discussion can be, let's say, faced in the, let's say, expressing what is the experience of each country, of each of you working on those specific issues. What is your approach? Okay, now I leave to you because I talk too much. More questions? Or more point of views or challenges or things you'd like to discuss further, even in other forums, not necessarily in the session of today, but something that can be in the agenda for any other group or any other work package in the MIG, or proposals, or in the platform that MIG is going to implement for the thematic clusters, which is also very relevant with all our discussions. So we are discussing how to implement different teams. So when those issues are going to be raised, we need to have a platform where we can exchange the experience, the good and the bad experience, and to move forward to solve the problems, to develop further, to correct, and so on. Yeah.
I think that we have a kind of challenge actually, and finally when we are now at the step of transforming our data, I think that more questions are raising up than real solutions. One of the first questions is what are the data that will be made INSPIRE compliant? And if you look to all the countries, some will say yes, all the data that are available. Others only the authoritative one. But what does that mean? Others at basic level. So this is there a first heterogeneity about what we should be made INSPIRE compliant, and probably we have to discuss about this at the end. What means a duplication? What means data sets that are valuable for INSPIRE? For me, it's the first case of heterogeneity among us. The second step, of course, is we have many opportunities also for, we remain at a generic conceptual level for the description of the data. Then we have to provide that into logical schema, physical schema, but probably with some difference in the result. So what does that mean? Is it an issue really in matter of interoperability? We could have different solutions, for example, for transforming a road network. That might be. That's another point. A third point is about the cross-border situations. I know that Inspire has not covered that really. I see that in Czech Republic they have presented a first approach. I feel very good with fixing point. The ELF project is also making this kind of processes, providing edge matching service. So for me, I think that here also we have to find some common solution or to widespread the solution that are existing. Yeah. Well, I will not speak about data content. That's another purpose. So it's different tracks or different thing.
You want to say something? Yeah.
Yes.
Yeah, and
okay.
François first.
No, it's just a short comment with regard. Obviously, I think that there is a problem of creating across Europe, I would say, thematic communities, which are where all the people. Sorry. That's better. So where all the people having to implement the INSPAR specification for a given theme can work, exchange practices and things like, because in many circumstances that will depend on the theme itself, how it is interpreted. So that is the first comment I would like to make, that we need to, for the Annex 3 specifically and Annex 2 as well, to create these grouping across Europe so that we can discuss and understand how we effectively implement the data specifications. There is another issue which I think is also another a big issue, is that we can't force the data producers to produce according to INSPAR and to produce according to the national data specifications. I mean, in many circumstances, the requirements at the national level are higher or have more requirements than what is in the INSPAR data specification, just because the INSPAR data specification were some sort of common level of understanding of the problem, where in each country there might be some specificities. And the question is, in my opinion, is also how we can automate the transformation from the national standards into the INSPAR standards, so that actually the burden is for the local or for the national producers, when they are several, is to meet the national requirements, and then there is something on top which converted the data set from the national standard into the European one in a way which is transparent for the user, but also more or less transparent for the data producer, so that he has to comply only to one data spec. And I don't know how that would be. There might be a room for exchange on that respect as well. Mm-hmm. So maybe WPS services or whatever can be involved.
Yep.
Just to mention, as I would like to share with you, especially with you, Natalie, in Spain we are facing this approach, how to go to the data and who is the responsible of the data. But this is also very time consuming, because all the different, you are talking at national level, but we are talking about regional or local level, and this is more and more complicated. And the issue is identify who is the responsible. On the first approach, we send on the monitoring and reporting a huge amount of information, a lot of different files for all the different themes and everything. But at the end, we are just realizing that this is not the realistic perspective. There are some themes that depend on the national, so we forgot about that, and some other that depends on the local. We are trying to build this common data model that could fulfill all the requirements from all the labels. But the main concern, and this is my personal vision, is that if we are not able to get these procedures, this process of inspired compliance, to put this on our daily basis flow, Inspire will not serve for anything. Yeah. So we need to have Inspire in our daily basis. But this is, apart from time consuming, it's very highly cost. And this is something that should be considered also from the old perspectives, I think.
Yeah, thank you. Anything else people want to say at that moment? If not, we can close the meeting and give you time for coffee break and a lot of ideas that you can take with you for discussion during coffee. Thank you very much.
Thank you.